All right, welcome everybody. So let's do this. For the second part of lesson number 8, let's look at the second page where it says find the zeros of g of x. So the idea is you want to make this thing equal to 0. And what was the thing we learned from last lesson? That you make this guy equal to 0, so it's x squared plus 7x plus 12 equals 0, and the other one is x squared minus 25, and you make it equal to 0. Okay, now this one, which factoring technique do you use for this one? You use the a equals 1, right? So what two numbers when you multiply give you 12, but when you add give you 7, okay? And then how does that factor? Pause the video and try and solve it, but it should just be x plus 4, x plus 3, right? And then you make it equal to 0, and then you draw your line, then you say x plus 4 equals 0, and x plus 3 equals 0, and x equals minus 4, and x equals minus 3. And everybody's happy, right? And what about this technique over here? If you haven't practiced this technique before, this is what we call a difference of perfect squares for this one. Because here, what do I mean by a perfect square? A perfect square is like, let's think about it. What is 1 squared? What is 1 times 1? 1. What is 2 squared? 2 times 2, 4. 3 squared, 9. Keep doing this. What I want you to do is try and do all of these all by yourself, just so you get the hang of it. So 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, 14 squared, and you can just keep going, right? So if you want to see the answers, so let me make an equal sign, right? Okay. So here, this is 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and you know, you can keep going, right? These numbers over here are the perfect squares, right? These are the perfect squares because you have a number, when you square it, it gives you that, right? So anytime you have an example such as this, where you have a perfect square over here, and this number over here is even, okay? Even, remember, even is 2, 4, 6, 8, 10, right? It's a multiple of 2. What you're allowed to do is you're allowed to factor it as x plus 5, x minus 5. Like, look at this one. If I have 100, how can I get that 100? So this is x plus 10, x minus 10, okay? And what is that, like, how do you check that, for example? What is x plus 10 times x minus 10, right? Because if I FOIL this, I better get this, because look, what's x times x? X squared. X times minus 10 is minus 10x. Positive 10 times x is positive 10x. And what's 10 times negative 10 is negative 100. But notice, what is this equal to? What is negative 10x plus 10x? Pause the video and just take a second. What is this equal to? It's 0. This just cancels. And what are you left with? X squared minus 100. And that's why this technique is very nice for a difference of perfect squares. What I want you to do is, if you feel like you need practice on how to do these, this is a really nice assignment you could do. Well, you could practice these two with me, and then I want you to go to the Delta Math and practice the difference of perfect squares. So here, this one's a little more advanced, but pause the video and try and see how this would factor, okay? If you want to see the solution, I'm going to make, notice that which one gives me the 16. Notice that it's a 4 and a 4, and it's a plus and a minus, right? And now it's not just going to be x, because what is x times x? X times x is x squared. But what do we want? We want x to the 4th, so you just make this x squared, right? And you know what the funny thing is? You see, this doesn't factor. And I'll explain in class why it doesn't factor. But look, can you factor this again? Is this a difference of perfect square as well? It is. How does this factor? Take your time, pause the video, and how does this factor? Okay? X plus 2, x minus 2. Okay? So notice that this guy over here, it doesn't factor one time, it factors 2 times. It factors once, and then this thing factors again to this, but don't forget to bring that down. Okay? Let's take a look at this one. How would this one work? Okay, so boom, 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 right? Okay, if you want to put a plus and a minus, sure. Then how do you get the 9? Okay, so 3 and 3. Now, how do you get the x to the 6? I want you to pause the video and take your time. How do you get the x to the 6? Well, this will just be x to the 3. Because what's x to the 3 times, what is x to the 3 times x to the 3? That's equal to x to the 3 plus 3, which is equal to x to the 6. And then here, how do you get the 36? Pause the video, right? Try and do it by yourself. So 6 and 6. And then how do you get y to the 10? This is y to the 5, y to the 5. Okay? And like, does this factor again? For like, you see how this part factored again? Does this factor again? No, it doesn't, because you see these numbers over here, 3 and 6, are not perfect squares, right? 3 and 6 are not one of these numbers over here. But you see, why did this one factor again? Because this 4 is a perfect square, and look at the power of this. This power over here, number 2, is even. If you look over here, this 3 and this 5, if it's not even, then it's odd. So that's why this does not factor. Okay. I really hope this helped. This was like a quick, short little thing. But practice this so you feel money with this. I'll see you.